In the quest to understand the fundamental nature of the cosmos, physicists have long sought a theory of everything, a single framework that unifies the forces of nature and explains the underlying structure of reality. String theory represents one such attempt, proposing that the fundamental building blocks of the universe are not point-like particles but tiny vibrating strings, whose different modes of vibration give rise to the diverse phenomena we observe in the universe. The origins of string theory. The roots of string theory can be traced back to the early 20th century, with the development of quantum mechanics and general relativity. However, it was not until the late 20th century that string theory began to take shape as a coherent framework for understanding the fundamental forces of nature. Inspired by the discovery of quarks and other subatomic particles, physicists hypothesized that strings could provide a unified description of gravity, electromagnetism, and the nuclear forces. The mathematics of string theory. At the heart of string theory lies a complex mathematical framework that describes the behavior of strings in various dimensions of spacetime. According to string theory, the universe consists of multiple dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. These extra dimensions are compactified or curled up at scales too small to be observed directly, giving rise to the rich diversity of phenomena we observe in the universe. Vibrating strings and particle physics. In string theory, the properties of particles such as electrons, quarks, and photons are determined by the vibrational modes of the strings. Just as different musical notes correspond to different frequencies of vibration on a guitar string, the particles we observe in the universe are manifestations of the vibrational modes of strings. By studying the vibrational spectra of strings, physicists hope to unlock the secrets of particle physics and the fundamental forces of nature. Supersymmetry and beyond. One of the key features of string theory is supersymmetry, a hypothetical symmetry between particles with integer spin, bosons, and particles with half-integer spin, fermions. Supersymmetry offers an elegant solution to many of the problems plaguing modern particle physics, such as the hierarchy problem and the unification of the fundamental forces. However, experimental evidence for supersymmetry has remained elusive, leading some physicists to question the validity of string theory as a theory of everything. Challenges and controversies. Despite its mathematical elegance and theoretical appeal, string theory remains a highly speculative and controversial area of research. Critics argue that string theory lacks experimental support and is too mathematically complex to make testable predictions. Others question the existence of extra dimensions and the viability of supersymmetry in the real world. Nevertheless, proponents of string theory remain undeterred, believing that it represents our best hope for a complete and unified theory of the universe. The multiverse and parallel realities. One of the most intriguing implications of string theory is the possibility of a multiverse, a vast ensemble of parallel universes coexisting alongside our own. In the multiverse, each universe corresponds to a different configuration of string vibrations and extra dimensions, giving rise to a dizzying array of possible worlds. While the existence of the multiverse remains speculative, it raises profound questions about the nature of reality and our place within the cosmic tapestry. Conclusion and reflections. As we conclude our exploration of string theory, we are reminded of the boundless potential of human curiosity and imagination. From the subatomic realm to the farthest reaches of space, the quest to understand the universe is a journey that knows no bounds. While string theory may remain a tantalizing enigma, it serves as a testament to the power of human intellect and the unquenchable thirst for knowledge that drives us ever onward into the unknown.